Assalamu alaikum students and welcome to MLS Online Virtual Classroom. Today is lesson number 8, which is covering the page number 18 and 19 of Oxford Discover 6. So let's begin. Students, today we're going to read the explanatory text, which is Overcoming Earth's Obstacles. Before this, I want you to be ready with your books open on page 18 and 19. Students, this text has around 3 portions or sections, with the first having an overview of how the engineers decide what we have to build and how we have to build. So this is the portion where the engineers decide what we have to build. Either do we have to build a tunnel or a bridge, and then if we decide one, either going for bridge or tunnel, what kind of bridge do we need? A suspension bridge, a beam bridge, or an arch bridge? And then we have to look for the soil composition. Is it a rocky soil, is it a sandy soil, or is it just a clay soil? And in the next section we have 3 kinds of bridges: a beam bridge, a suspension bridge, and then an arch bridge. And then apart from that, in the third portion we have tunnels, and how tunnels are basically made, what kind of strategies they adopt, and how they are actually dug. So let's begin.
We all know that the simplest way to get from point A to point B is a straight line, but Earth's varied geography often makes that problematic. There are rivers, mountains, gorges, and many other landforms that have to be overcome. For centuries, engineers have used bridges and tunnels to go over, under, or through these obstacles. Before they decide what type of bridge or tunnel to build, however, they consider such factors as the distance to be traversed, the composition of soil at the site, and what needs to be transported. Is it a person? That's fairly easy. Is it 10,000 tons of coal? That's not so easy. Is a bridge always better than a tunnel? It depends on the situation. Bridges are usually cheaper and easier to build than tunnels, especially when they're needed to cross a waterway. On the other hand, tunnels are less vulnerable to weather and can carry more weight. Types of bridges. If engineers decide to build a bridge, the first problem they face is choosing which type to build. To decide this, they might ask themselves what the bridge needs to cross and what will travel across it. There are 3 main types of bridges: the beam bridge, the arch bridge, and the suspension bridge. Each type is constructed differently and is best suited to a different situation. The simplest and most common type of bridge is the beam bridge, which is a horizontal surface with vertical supports at either end. Beam bridges are often used for short spans of distance, but there are some long beam bridges. The longest in the world, at 38 kilometers, is the Lake Pontchartrain Causeway in the United States. You can build your own beam bridge by placing a ruler between 2 stacks of books. Try adding or removing supports beneath the ruler to see how it affects the strength of your bridge. Arch bridges, first built by the ancient Greeks, are often used in places where it's difficult to add extra supports. With an arch bridge, the weight of the arch is supported by structures known as abutments. The arch itself is what gives the bridge its strength. In fact, even today you can see arch bridges and aqueducts, bridges that carry water, that were built by the ancient Romans. They're a beautiful sight. The suspension bridge is a more modern bridge design. In the past, these bridges were often suspended by ropes, but today they commonly use strong steel cables. The load-bearing part of the bridge, which supports the weight of people, cars, or trains, is suspended from large vertical towers. Suspension bridges are lightweight and strong and can be used to traverse long distances. The longest example of a suspension bridge is the Akashi Kaikyo Bridge, or Pearl Bridge, in Japan. Tunnels. Bridges are great for getting across things like rivers, but sometimes you need to get under or through something, such as a mountain. Digging a tunnel can be the best way to do this. Tunnels are long, narrow passages that allow people, cars, trains, and even animals to cross safely from one side of an obstacle to the other. We build tunnels to carry water, dispose of waste, and protect cables used for power and communication. Tunnels are also used for subway trains or to create walkways under city streets. Like bridges, tunnels must be constructed with careful planning. Engineers have to assess the kind of soil or rock they need to dig through. If the tunnel is near water, they'll have to pump the water out as they dig. In the past, engineers often used explosives to blast tunnels through rock. Today, they dig large tunnels with a digging machine called a borer. When the Channel Tunnel was built, to link the United Kingdom and France, the French and English engineers were digging for months on either side until they eventually met in the middle. Now, this tunnel carries millions of people between the two countries. To overcome Earth's many obstacles, engineers of the future will be constructing even larger and more advanced bridges and tunnels. These projects will not only bring us the goods and services we need, but will also help to bring us closer together.
Alright students, now that we have the text read out, we're going to discuss few points. So coming back to the very first portion, we have seen that what is the problem? The landscape is the problem, which defines the obstacles as well. As Earth is not even all around the world, somewhere we have gorges, mountains, rivers, and many other landforms like deserts and stuff. We have to overcome them by making or building a bridge or a tunnel. Now, what is gorge? We have seen it here. A gorge is a narrow valley with steep rocky walls. So it's like a very narrow passageway between two rocky mountains. Then we have the word traversed. Traversed means to travel across a distance. Then we had the word vulnerable. Vulnerable means something which is at risk or in danger or is unsafe. So here it says that tunnels are less vulnerable to weather and can carry more weight. So they are not at risk of carrying more weight, which means they can carry more weight than bridges, whereas bridges are vulnerable to weight because they can, if the weight becomes above the certain limit, they can collapse as well. Then here we had three types of bridges: the beam bridge, the arch bridge, and then the suspension bridge. The beam bridge is one of the most common bridges. Here we have the arch bridge as well, and they were used by the ancient people and in ancient times, but they are really beautiful and strong as well. Aqueducts can also be constructed by using arch bridges as well. Now we had abutments, right? The support of the bridges where all the weight of the bridge rests. So basically they have abutments right below this point where the weight of all the arches were supported by. So they had these abutments right in the water base where the bridge would touch the ground. So these were abutments. Moving on, the suspension bridge, they said, is far more easier, far more light, and far more strong as well. So they can carry more weight than the other two bridges and are easier for long distances as well. And previously we had ropes which used to suspend the bridges, and now we have strong steel cables. Moving on to the tunnels, we heard listen that the bridges sometimes are not an easier or efficient way, so we then dig a tunnel because it might be even cheaper, it might do the service best, and it might carry more weight as well. And bridges, how are the bridges made? First, the soil testing is done. is it a firm soil, is it a soft soil, is it feasible to make a tunnel or not, and what will be the repercussions of it if we do the blasting or not. So previously they used explosive material to blast the rock, and now they have this kind of machine which is called a tunnel borer. So basically this churns, this moves, and cut the rock in a way we cut the rock with boring machines for water boring, you know. So this is in a similar fashion, cutting the rock horizontally. And then they talk about the channel tunnel. We also discussed in the previous lecture about channel tunnel, which is also called channel, and it is between the United Kingdom and France, which is underwater undersea tunnel. Then they said that even in the future we will be making more bridges and more advanced tunnels to meet the daily requirement or the ever increasing environment of support of transporting goods and people. So students, that was the end of lesson number 8. I hope you have understood it well. Now what you have to do is you have to make a mind map, a rough mind map of the text that we just read. You can go through it yourself 2 to 3 times and suit it yourself, but you have to make a mind map. So that was all for today. Thank you and Allah Hafiz.